All right, so I've got us recording. When I post this, if I put it on YouTube, I'll be sure to blur out everybody's faces so nobody can see. So this whole session will be just focused on unit conversions. And in the video lecture, I showed you all of these unit prefixes that we can include. And these unit prefixes are down here. There's actually even more than this, but it's just overwhelming to memorize all of these. So if you're in Chem 121, I want you to memorize only the ones that are highlighted. So mega, kilo, centi, milli, and micro. And in particular, what we're gonna do today is we're really gonna focus in on these values right here, which basically just indicates that if you're talking about mega, you're talking about 1,000,000 of the base unit. If you're talking about kilo, you're talking about 1,000, and then so on. And then I have these other useful conversions here. I would never expect you to memorize these because that's just crazy. I would give you any of these unit conversions on an activity or exam or quiz or whatever. So let's go ahead and do some practice. And let's go down to this worksheet that I pulled over. So we're going to use our conversion units to convert all of these values as shown. So let's do the first one. And I always like to start out with what we know, which in this case, the value that we're given is 1.26 times 10 to the 4. So I'm just going to go ahead and write that down here. So 1.26 times 10 to the 4th centimeters. And then I would just want to start my conversion. So I know I'm going to need some sort of conversion factor. And in this case, we need to cancel out centimeters, right? And our goal is to work our way all the way to meters. And hopefully we can just do that in one step. But to cancel out centimeters, that means that centimeters must be on the bottom. That way the centimeters unit will cancel and meters must be on top. So now the question is, which number goes on top and which number goes on bottom? But let's go ahead and write out our conversion factor. And to find our conversion factor, there's a few ways to do this. Let's think about 1 centimeter, right? Centi is one of the prefixes that we had up above. And centi, if we go and look up above, is 10 to the negative 2, right? So centi is basically like saying 10 to the negative 2 meters. So we can rewrite this and say 1 centimeter is the same thing as 10 to the negative 2 meters, because really all this is doing is being equivalent to that. Make sense so far? I know it's kind of hard being online, but we'll go ahead and plug this in. So let's go ahead and plug in these numbers. So we know that 1 is going to be paired with centi. So I'm going to put that down here. And we need to make sure that our numbers are always paired with the correct unit, which means that 10 to the negative 2 over here must be paired with the meters unit because that's what's right here. So I always double check that my units cancel. That's the first thing. And then I double check that my number is paired with the correct unit. So if we go ahead and we do the math on this, you can try plugging it into your calculator, but it should give us a value of 1.26 times 10 to the 2 meters. So this would be the final answer for this. Does that make sense for everybody? It's a nice one-step starter problem. If it doesn't make sense, you can always turn off your mic and say, wait, stop. I'm okay with that. All right, so this one's pretty straightforward. It's nice because there's only one conversion factor, but let's do the next one, which will actually involve more than one conversion factor. So again, in this one, I like to start with what I know, which is I have 5.889 times 10 to the 17th microliters. So that's that weird little U-type symbol. And our goal is to get all the way to kiloliters. So let's go ahead and write out some conversion factors up top. And let's think about what we might need. So in this case, we definitely want to cancel out microliters. So just like above, I want to put that on the bottom here. And the question is, can we go directly from microliters to kiloliters? Let's just avoid doing that right now. And let's just go from microliters to liters first. So let's think about how we can do that. So we can say oops, wrong color. 1 microliter is equal to some number of liters. So if we go back and look at the chart, our goal is to figure out what this prefix micro stands for. So we can go back up and we can say, micro stands for 10 to the negative 6. So now we can say, just like we did in the previous problem, that we should have 10 to the negative 6 liters, because we know that this value is basically replaceable for that micro symbol. Okay, so let's plug in everything here. We've got 1 microliter. So 1 needs to be paired with the microliter unit. And then over here, we've got 10 to the negative 6 liters. So I'm going to put 10 to the negative 6 with my appropriate unit. Oops, it's not letting me change colors here. There we go. 10 to the negative 6. And if you want to highlight and color code like I can, you're welcome to, but you don't have to, obviously. And we can go ahead and now cancel out microliters, and we've double checked that our number is paired with the right unit. But the answer we need should be in kiloliters. So we need to keep on working our way through. So in order to do that, what we're going to do is try to cancel out liters next. So I'm going to put liters on the bottom now. That way our liters units will cancel out. And let's put kiloliters on top. So let's do our second unit conversion. So this was 1 unit conversion that we had here. Our second unit conversion, we said we need to do something similar. So 1 kiloliter, let's figure out what that is in liters. So if we go ahead and look for what this kilo unit stands for, we can go back up to our chart and we could say, well, kilo is 10 to the 3rd. So I'm going to go ahead and put that in down here. And we could say this is 10 to the 3rd liters, because we said that this is basically just interchangeable for that prefix. Okay, so let's go ahead and do the same thing. We're going to put 1 with the kiloliter. So now it's actually going to be on top. And then for our other unit, which is liters, we need 10 to the 3rd to be paired with it. So I'll go ahead and write 10 to the 3rd. And let's just make sure we highlight it and be consistent. And double check that our units cancel. Liters and liters cancel. We're left with kiloliters left over. So the correct answer for this one, if we type it into our calculator, should be 5.889 times 10 to the 8th kiloliters. Does this make sense so far for everybody? If you want, you can unmute your mic for a second. We can kind of touch base with everybody.
Yeah, I'm just I'm trying to get through the 10 to the x power, because I did something wrong where I came up with 10 to the 14th power. So I'm moving the digits the wrong way.
For your calculator?
No, I just did the basic calculation with the, what is it, the 5.889 divided by, let's say, 1,000 or a number, but then I just added the 10 to the x power or subtracted 10 to the x power. I just got to figure out why I'm moving the decimal the wrong way.
Yeah, so one common mistake I see students make is they set up their problem correctly, but they struggle in putting all their data into their calculator. So I always tell students, use more parentheses than you think you'll need. So
Yeah.
for example, up here, maybe put a parentheses around that -6. Oftentimes that helps avoid any mix-ups like that. But if you are really struggling with the calculator stuff, let me know and we can even do like a little video. I typically avoid doing calculator stuff in my broader lectures because everybody has different calculators. So I don't want to cause more confusion.
Right.
But if you need help, just let me know and we can try to do that.
Okay.
Yep.
Thank you.
Yeah, no problem. All right, let's continue on to the next one. So the next one's 8.47 times 10 to the -2 kilometers to megameters. And so you can tell clearly the capitalization matters a lot, right? So mega is capital M, milli is lowercase m. So we need to be very careful with our capitalization. So let's go ahead and do the same thing. So we've got 8.47 times 10 to the negative 2 kilometers. And we know we need to cancel out kilometers, so I'm going to put that on the bottom. And I always think it's easier to go to the base unit than to try to jump to some other derived unit. So I'm just going to go kilometers to meters. And this will be a lot easier because if we think about it, we can say 1 kilometer, the prefix K just stands for 10 to the third. Right? So these units, 10 to the third and K, are just interchangeable. So just like before, we would pair 1 with the kilometer and then 10 to the third with the meters. So if you want to, you can highlight this and say 1 was paired with the kilometer, and then 10 to the third was paired with the meter. And so now we've got things in the right position and we're canceling out kilometers. And then for the next one, we can cancel out meters. So I'll put that on bottom this time so it cancels out. And our goal is to get to megameters. So we need to find the relationship between meters and megameters. So if we think about, well, what the heck is 1 megameter? We need to figure out what mega stands for. So if we need to, we can cheat and look at our chart. Say mega, in this case, is going to be 10 to the 6th. So it's 1,000,000. So let's go ahead and write this out. This is basically going to say that this is equal to 10 to the 6th meters. These are both interchangeable right there. All right, so now again, we want to make sure everything's paired with the right unit. So 1's paired with megameters. I'll put that on top. And then 10 to the 6th is going to be paired with my meter unit. So we can go ahead and say these are paired correctly and these are paired correctly. Another common mistake I see students make is they accidentally flip the numbers on accident. And we can double check that meters cancel, which leaves us with a final unit of megameters, which in this case, if we plug it all into our calculator and we double check everything, should give us a value of 8.47, let me zoom out a bit, times 10 to the negative 5 megameters. Does this make sense for everybody? You can give me the thumbs up if it makes sense in the... All right, looks like a few thumbs up there. Perfect.
So I do have a question though. So
yeah.
I'm getting the right answer, but I'm actually doing it manually just by adding and subtracting the exponent, which actually is a little easier because anytime I try to put it in the calculator, I always get a syntax error. So
yeah.
Is it just easier to do it that way, or to do it, you know, just adding and subtracting based on multiplication and division?
Yeah, you've got a really good point. So one trick, if you don't want to bother with the calculator because you just run into too many calculator errors, is to basically say, all right, we're going to take this 2 and add it to a 3, right? So after that point, it's going to be 10 to the 1st. But then because the 6 is on the bottom, we're going to subtract out 6, which leaves us with a net of negative 5. So absolutely, if you want to do it that way and you can do it in your head fast, go for it. I know some students, they kind of get nervous with that and they're like, no, I want the safety net of the calculator. Whatever works for you. Everybody learns differently.
Okay.
Yep, great point. All right, so let's do the next one. And then once we get past this last one, we'll start doing non-metric conversions, which get a little bit trickier too. So this first one, or this last one here, is 4.550 times 10 to the 12th milligrams, and our goal is to get to megagrams. So just like before, I'm going to put milligrams on the bottom, that way it cancels, and I always prefer to go to our base unit and then work my way back out. So I'm going to do a milligram to gram ratio here. Just like before, I'd say, well, what is 1 milligram? Well, milli, in this case, is going to be equal to 10 to the negative 3. So it's 1/1000th of a gram. So just like before, I can say, well, 1 milligram, let me keep this color coding the same, is going to be on the bottom, and 1 is always paired with that milliunit. And then over here, 10 to the negative 3 is paired with the grams unit, so I'll put that on top. And we can go ahead and highlight all of this. All right, then our next one, we'd say, well, look, we've got to our base unit, but now we need to figure out how to get from our base unit to megagrams. So we need to cancel out our base unit, and we need to get to megagrams. So I'd say, well, 1 megagram is equal to 10 to the 6 grams, because we said that mega stands for this 10 to the 6. So if we go ahead, we can plug this in, and we can say 10 to the 6. Whoops, sorry, wrong side there. I made my own mistake. 10 to the 6 should be paired with the grams unit, which means it's going to be on the bottom. And 1 is going to be paired with this milligram unit. So I'll put that there. So now we've got the proper positioning, but like I said, students will flip-flop it. Occasionally I do too when I'm working too fast, so it's always good to double check. And now we can cancel out grams, and we're left with milligrams. So let's try checking using that simple math tool, right? So like we were saying before, you can take 12 and subtract out 3. So that gets you to 9. And then over here, because this is on the bottom, it's also equivalent to subtracting. So we do 12 minus 3 minus 6. So that should be a leftover of 10 to the 3rd. If you need to, it's more than fine to use your calculator though, but we'll go ahead and just do this quickly. We said we'd have 10 to the 3rd left over, and our unit would be megagrams. So feel free to use scratch paper, color code, whatever you want. I often color code, as you probably have noticed in my videos. It's a lot easier for me to keep track of things if I match them with a specific color. Let's do the next one though. So the next one, we've got 29.73 inches. And we're trying to get to centimeters. So we can go ahead and put inches on the bottom, but inches aren't a metric unit. So we're going to need a different conversion here. So let's go ahead and look and see if we can find inch to centimeters or inch to meters, something to get inch into a metric unit. So if I go and look at it, immediately right here, I see that 1 inch equals 2.54 centimeters. So let's go use that as our unit conversion. So let's write that one above. So 1 inch equals 2.54 centimeters. So it looks like we can just make a ratio of inches to centimeters right off the bat, which is good because we don't need to do any more conversion. But 1 is going to be paired with the inch unit. So I'll put that down here. And then 2.54 is going to be paired with the centimeter unit. So I'll go ahead and highlight all of these, and we've canceled out our inches. And if we do our math, we need to make sure that we have an appropriate number of sig figs. And it is confusing. In fact, the SI leader was asking me about this. I believe this is an exact value, meaning it's not a measured value. So in this case, we ignore sig figs for this. So that means over here, we should have 4 sig figs. And because that's our only value that's measured, our final answer should have 4 sig figs. So we can go ahead and type this into our calculator, and I would get 75.51 centimeters. Does that make sense? Give me a thumbs up if it does.
So it makes sense, but when I was looking at commonly used, like table 1.3 in our book, it gave me the conversion of 1 centimeter equals 0.394 inches. When I punched it into my calculator, I got 75, but then I got 0.4568. So my answer would be 75.46. how do we know which conversion factor to use?
Yeah, that's a good point. I'm not 100% positive that this is an exact value, and your question makes me think that maybe it's not an exact value. Really, my main concern as a professor is that you set up the problem correctly and you do the math correctly. In fact, in my video that I'm going to put out on Friday, one thing I like to do is if you answer a question on quiz or homework and you're like, my answer's right, there's just some nitpicky thing going on there, is argue with me. And what I mean by that is just email me and explain yourself and I'll give you points back. So if you run into something like that, my main thing is seeing that you've set up the conversion correctly and that you're following sig fig rules to the best of your ability. Make sense?
Yes, thank you.
Okay, perfect. Let's do another one. So this next one, we've got 185 pounds, and we need to convert this to kilograms. So just like above, we need to cancel out pounds. So I'll put that on bottom. And let's see if we can find a way to get pounds to a metric unit. So let's go back to our chart. We'll see if we can find anything in there. So mass, we're close. We've got 1 pound equals 454 grams, or even better yet, we've got a direct conversion from kilograms to pounds. So 1 kilogram is 2.2 pounds. All right, so let's go write that down. We said 1 kilogram equals 2.2 pounds. And if we want to be really specific, this is a number that has more digits. So 2046 pounds would be one with more digits. In general, though, when I'm looking for sig figs, I want it to be based off of your original measured value, not one of your conversion factors. But this will help us along. So we've got pounds on bottom, and we've got a ratio where you can put kilograms on top. Whoops. And we know that 1 is paired with the kilograms unit. That's what we're seeing over here. And the 2.2046 is paired with the pounds unit, which is over here. So we can go ahead and do our math, cancel out pounds. And if we do this, I'm getting a number that's pretty large, but it should only have 3 sig figs. So it should be 83.9 centimeters, or sorry, kilograms. Is that what everybody else is getting? Kind of trusting my calculations.
No.
Are you getting a different number?
Yeah.
Okay, let me double check.
84.09.
Yes, correct. That's what I had too.
Yeah, so I just used the 2.2 and not the 2.2046.
Oh, so you just used 2.2?
Yeah.
Yeah.
Okay, yeah, if you use this full number with more digits, it does look like it's coming out as 83.9. But like I said, I'm not going to be super nitpicky. So if you use 2.2, I'd be fine with that as well. Does that sound okay?
See?
The big thing is it really just depends which conversion factor you pull from. My main goal is not to confuse people with this. I just want to see it set up correctly. So as long as you have the 2.2 on the bottom and you're canceling out pounds, that's what I care about. That's the big, most important thing. All right. So next one, we've got to convert centimeters to feet. So 33.44 centimeters. We're going to have to cancel out centimeters, so I'm going to put that on the bottom. And let's see if we can find a way to convert centimeters to feet using our chart. And we'll see what we have in our chart that could be helpful. So we're dealing with length. So I'm seeing right here, we've got centimeters to inches, but I'm not seeing centimeters directly to feet, right? But down here, I'm seeing another one. So you see how over here we've got inch and inch in both of these? That means we can use both of these in sequential conversions to get to the appropriate answer. So this one's a little bit trickier. So we know 1 inch is 2.54 centimeters and 1 foot is 12 inches. So let's go ahead and write out these. So 1 inch equals 2.54 centimeters. That's 1. And then we said 1 foot equals 12 inches. Okay, so now it looks like we need to use this one in our first situation because this is the one that has centimeters in it. And this is an inch to centimeter ratio, so I'm going to put inch on the top. In addition, the 2.54 is paired with the centimeters unit, which means the 2.54 should be on the denominator with the centimeters unit, where 1 is paired with the inch unit, and therefore should be on the top with the inch unit. Okay, so now we're set up. We can cancel out centimeters and centimeters. But now we need to use our second unit conversion. And to apply the second unit conversion, we need to cancel out inches. So I'm going to put this on the bottom in order to cancel out the inches. But now we've got a foot to inch ratio. So I'm going to put foot on the top. And just like before, 1 is paired with the foot unit. So I'm going to put that 1 on top with the foot unit. And then 12 will be on the bottom with the inch unit. So now I'm set up, I'm ready to go. My inch units are canceling and I'm left with feet. And let's see if I did my math correctly here. I'm getting 1.097. And like I said, I always look at my first measured value. This had 4 sig figs, which means that this final answer should have 4 sig figs as well. Some students get confused and they're like, well, what about this? That only has 2 sig figs, but that's an exact ratio. It's not a measured value, so we're just going to ignore sig figs here. And I normally just ignore sig figs here as well because I never remember if this is exact or not. So like I said, as long as your starting measurement sig figs matches your ending one, I'm more than happy with that. So there we go. I'm getting 1.097. Make sense so far?
So when I was doing the calculation, I kind of just skipped over this step and just went ahead and multiplied the 12 by 2.54. So I didn't exactly show that additional 1 foot equals 12 inches step, but I got the same answer because I did the calculation. I just didn't show it. Would that be something you'd want us to show, or if we can skip that, showing that step, you'd be fine with it?
That's a good question. I would say in a normal non-pandemic situation, it's a lot easier for me to grade handed in work on paper if I see every step worked out because I can identify where an error happened. But I would say in an online environment where you just have to type in the right answer, however works, as long as you get the right answer. Yeah, teaching online is kind of not ideal. So I've had to adjust the way in which I collect work just based on the nature of online teaching. Does that make sense?
Yeah.
Okay. But yeah, normally if somebody gives me the wrong number, I want to know where the error happened. So it's nice to see it broken down into steps. So let's do the next ones. I think we only have a few more. They get a little bit harder as we go down. So we've got 9.445 gallons. Oops, G-A-L for gallons. And we need to go to centiliters. So let's cancel out gallons first and see if we can find a way to convert gallons to our metric unit, which is liters. So let's go back up. And I'm just going to erase all of this, and let's see if we can find gallon in here. So gallon is a volume measurement, and it looks like a gallon is 3.785 liters. So let's go write this down. So 1 gallon equals 3.875 liters. So it looks like we have this ratio, which means liters must be on the top. In addition, the 3.875 should be on the bottom. And the 1 should be paired with the, oh, shoot, I even mixed up. Holy cow. I need more coffee, I guess. 1 should be paired with the gallon unit, right? So that's going to be on the bottom with gallons. And then the 3.875 should be on top with our liters unit. So like I said, I even goof this up sometimes when I'm moving too fast. So we've got that conversion set up, but we need to solve in centiliters. So we need to get rid of our liters unit, which is going to be on the bottom, and we need to get to centiliters. So centiliters would be on top. Let's see if we can find this ratio. So 1 centiliter has this centi unit in here. And centi, if you remember, is equal to 10 to the negative 2. So these are equivalent to one another. So we can go ahead and say 1 centiliter equals 10 to the negative 2 liters. So we want 1 centiliter, or 1 to be paired with the centiliter unit. And then we want 10 to the negative 2 to be paired with our liter unit. So we'll go ahead and put that in down here. So let me check on my calculator. I actually didn't prep this one. So I've got 9.445 times 3.875. And I'm getting 3657.104. However, because we started with 4 sig figs over here, let's just try to keep 4 sig figs in our final answer. Okay, so in order to keep this at 4 sig figs, I'm going to go just to 3657 centiliters. The reason we're not rounding up is this number following our 4th sig fig isn't 5 or greater, so we don't need to worry about adding that up or rounding that up. Did I do this right? 3 point. Let me double check my conversion up here. So 1 gallon equals 3.785. Holy cow. I thought something was off. Sorry, I flip-flopped these numbers. 785. That's going to change things. So let's go ahead and fix these numbers here. Sorry, I didn't have time to fully do all the math on all these problems before we started. $9,325, but like I said, this needs to be 4 sig figs, so this would be 3,575. So we need these 4 sig figs, but because this last value is greater than 5, we need to round up. So this would be the appropriate answer for this one. Make sense there? Give me a thumbs up.
I have a question.
Yeah.
So when you're doing the sig figs, you see the first number is 9.445.
Mm-hmm.
On your answer, sure, we're going to get the 4 numbers, but do we have to have a decimal or no?
Yeah, that's a good question. If you included this decimal here, that would be fine too. But you don't have to here because these are all non-zero numbers. It's implied that they're all significant.
Okay.
Does that make sense?
Yeah, and then I would just always include by the end. I don't move to make it look like the first number.
No, however, that brings up a good point. Let's write this out in scientific notation, right?
Mm-hmm.
So if we imagine this decimal here and we want to write this in scientific notation, we would have to move it behind the 3.
Mm-hmm.
So we could say that this would be 3.575 times, would it be 10 to the positive 3 or negative 3?
Positive.
Yep. So we'd say positive 3 centiliters.
Mm-hmm.
The great thing with this is that this has 4 sig figs.
And this has 4 sig figs, meaning you can write it out either way.
Perfectly happy with either answer.
Okay, yeah, because my husband is a chemist and he keeps telling me that I should always convert everything to scientific notation. Yeah. So every time I'm doing this, I'm like, he wants me to put a decimal, and I'm like, well, but he doesn't show a decimal. So
yeah, that's a good. It's a good point. I'll try to be really specific if I'm looking for that. I will say your husband sounds like a chemist. We're inherently stubborn people, and once we do things one way, we want to stick with that. But I try to be flexible.
Okay.
Yep. That's funny. All right, let's do the next one. So we're going from centimeters per minute to miles per hour. So this one's going to be pretty tricky. So we've got 743.9, but it's centimeters per minute. So that means centimeters is going to be on the top. Let me even move this a little bit. And minutes will be on the bottom. So another way of writing this is you would go 743.9 centimeters in exactly 1 minute. So we could express it as this ratio. All right, let's try to pick a unit to cancel out. So when I'm looking at this, the distance unit in this one is centimeters. And then the distance unit in this one is miles. So let's try to focus first on converting centimeters to miles, and then we'll worry later about minutes and hours. So let's first cancel out centimeters, but now it's going to be weird because to cancel out centimeters, we need centimeters on the bottom. So let's figure out how to get from centimeters to miles. So let's see in our chart if we have any good mile relationships. So over here, it looks like the only one we have for a mile is 1 mile equals 1.61 kilometers. So let's go and write that down. So I'd say 1 mile, equals 1.61 kilometers. All right, but this doesn't really help us with the centimeter part, right? So now the question is, well, what in the heck could we do? Well, like I said, oftentimes if I'm dealing with one of these derived units like centimeters and I'm stuck, I just go to my base unit. So I would say let's focus on converting centimeters to meters, and then maybe we can go from meters to kilometers in our next step. So this would be one conversion factor. I'm just going to kind of tuck this away so that we remember it. And I'm going to slide it over here. But let's keep in mind the centimeter conversion. So we know that 1 centimeter, centi, is 10 to the negative 2. So maybe this would be our other conversion because we know that these two numbers, or 10 to the negative 2 is the same as the C prefix. Okay, so let's do this conversion. We would have 10 to the negative 2 on the top and then 1 on the bottom with our centimeter. So we can cancel out centimeters here. All right, but now we need to cancel out meters. So I'm going to put that on bottom. And our goal at this point is to start getting to kilometers, so then we can eventually get to miles. So this one is one of the harder problems we'll see. So we know that kilometers would have to be on top. And if we think about the relationship here, we can say, well, 1 kilometer is equal to 10 to the third meters, because we know that prefix K is the same as 10 to the third. So now we can start canceling out our units. 1 is paired with kilometer, 10 to the third is down here. And now we've canceled out our meters. So now we can use that unit conversion we looked up in the very beginning. So now we can say, let's cancel out our kilometers. And let's put miles on top because we got a kilometer to mile ratio we can finally use. So over here, we've got 1 paired with my mile unit, and then 1.61 paired with my kilometer unit. So this was kind of a lengthy conversion just to convert from centimeters all the way to miles, but we've finally done step 1, which was this conversion right here. All right, but we're not done yet, because if we think about the units that are left over, we've got miles per minute when we want miles per hour. Okay, so let's go ahead and start working on our minute one. If we think about where the minutes are located, they're on the denominator. So to cancel out minutes, we need to put them on the top. So I'd say minutes go on top. And if we think about hours, we would have to put that on the bottom, right? That way these minutes units over here cancel appropriately. All right, so we need one more conversion. And we need to find a relationship that compares minutes and hours. So how many minutes are in 1 hour? Most people know that would be 60 minutes is equal to 1 hour. So this would be our last unit conversion. And we could go ahead and we could say 60 should be on top with the minutes unit. and then 1 should be on the bottom with the hour unit. So now if we think about our units that are left over, we still have this miles unit left over on the numerator side, and then we've got this hour unit left over on the denominator side. So let's go ahead and plug everything in. So I'm getting 743.9 times 10 to the negative 2 times essentially 10 to the negative 3, or you could say 1 over 10 to the negative 3 times 1 divided by 1.61 times 60. All right, so let's check the math here, and hopefully we're all getting similar answers, but I'm getting 0, whoops, keep the color the same, 0.277229814, and this would be miles per hour. However, if we look over here at our starting value, we had 4 sig figs. So I really just want my students to try to stick with the same number of sig figs that we started with. So let's pick the 4 sig figs here. So these would be our first 4 sig figs. This one is less than 5. So we don't really need to worry about rounding up. So I would just go ahead and I would change this to 0.2772 miles per hour. Does this make sense? I know this one was arguably the hardest.
Yeah,
I will say,
can you walk through what you multiplied everything by and what you divided by again?
Yeah, so here's another good strategy is if you go ahead and multiply the numerator altogether, come up with the answer for that, and then multiply the denominator together, come up with the answer for that separately, and then divide the two. Sometimes you avoid some of the problems with that. Does that make sense?
Yeah, that's what I tried to do, but I don't think I did it right because I did not get the right answer.
Okay, how about this? Let's do this one first. So I'm gonna just have us solve this portion, but we're not even gonna use our calculator for this. Okay, so if we think about 10 to the negative 2 times 1 over 10 to the negative 3, what would that be? So let me even change this. What would
10
this
to the
be?
negative 5th.
Yep, so this is going to be equal to 10 to the negative 5th. So if you need to, you can just say, well, if that's the case, then we could say, well, 743.9 times 10 to the negative 5th. So if you want to do this in your head, sometimes that avoids calculator mistakes. And then we could say times, and then I do this in parentheses in my calculator, 1 divided by 1.61. And then I could say times 60. Does that make sense?
Yeah.
Yeah, oftentimes the biggest mistake I find is just typing stuff into the calculator. You forget one parentheses and it throws everything off. So if you can overuse parentheses, or even better yet, like I forgot who suggested it. Somebody else suggested just doing it in your head for the 10 raised to whatever power conversions. Sound good? I will say these problems like this one, this would be far and away the hardest I would throw at you. So if you can handle problem number 9 and get it done correctly, you've got this down. You've got unit conversions. All right, let's do the last two.
So,
Oops.
sorry, my question
No, you're fine.
is for the exam coming up that's due next Sunday.
Yeah.
You want us to memorize mega, kilo, centa, milli, and micro. If you're going to throw us something like a number 9 question, will you give us the conversions needed?
Yes, absolutely. So any other conversions beyond, let me erase this, beyond the highlighted ones, I would give you. The main reason we want you to memorize the highlighted ones is the vast majority of students in 121 are going into allied health careers. and these are the most common units in allied health careers. So for example, if you weigh somebody, it's usually done in kilograms.
Right.
If you're adding something to an IV, it's often done in micro or milligrams. If you're measuring a foot, you might do it in centimeters. So things like that. We just want to make sure students are prepared for their career.
Okay.
Yep.
Dr. Engel, so just to confirm, so we're not to bring any type of conversion chart when we take our test. I mean, I understand you're not going to see it, but that's what you're saying, no conversion charts.
Yeah, these highlighted ones I'd want you to know.
Okay.
You can obviously have a periodic table and a calculator.
Okay.
Beyond that, I'll be brutally honest, it's an honor system. I want students to challenge themselves.
Yeah.
And the only way we can learn sometimes is by making mistakes.
Okay. I just wanted to understand that. Thank you.
Yeah. I know it's stressful taking exams, so the biggest thing I recommend is use scratch paper. Even though it's on a computer, have scratch paper out, write everything out like you would on a normal face-to-face exam. All right, so the price of gas in Belgium is 123 euros per liter. So let's do this one. So if you have 1.23 euros, you can buy 1 liter of gas. So let's figure out a conversion. And let's just pick one of these numbers to convert first. So I'm going to pick the money unit to convert first. So up at the top, we had a conversion for euros to dollars. And this is not based on today's market conditions. I think it's a lot better now. So $1 is 0.75937. So let's write that down. $1 equals 0.75937
euros. Okay, so now we can
cancel out our euro unit, which would have to be on the bottom, and we can go directly to our dollar unit on top. And 1 is paired with the dollar, and 0.759, let me erase this, 37 is going to be paired with the euro unit on the bottom. All right, so now we've canceled out our euros, which is good. And we've got our desired unit of dollars taken care of. But we haven't done anything with our liters yet, right? And we need to convert liters to gallons here. So let's see if we can find a relationship for liters and gallons. So I'm just going to box this off, and we'll go back to our chart. So let's see, we said 3.785 liters is equal to 1 gallon. So we'll scroll back down. And this would be another conversion we could use. So this time we need another conversion, but because the liters is on the bottom, that means in order to cancel it out, we must have liters on the top and gallons on the bottom. So that would allow us to cancel out the liters appropriately. And the 3.785 must be paired with the liter unit. So we'll put that on top, not the bottom. And we'll put 1 on the bottom with the gallon unit. So now we've canceled out liters and we're left with gallons. So let me check my math here. And this is one I would do in my calculator. So 1.23 times 1 divided by 0.75937 times 3.785 is giving me 6.13 dollars per gallon. Does this make sense? And I chose 3 sig figs here because we started out with 3 sig figs in our starting measurement.
Yeah.
Perfect. Yeah, if you've ever been to Europe, you will notice immediately that gas is crazy expensive. We went to Iceland a couple years ago and we spent a fortune on gasoline.
Yeah, in Brazil it's the same. They charge per liter, not per gallon, so it's awful.
Yeah, the crazy thing in Brazil is a lot of what they sell is ethanol, not gasoline, which is kind of cool.
Yeah.
Let's do the last one. So last one. A sample of an unknown metal has a mass of 35.4 grams and a volume of 3.11 centimeters squared, or cubed, excuse me. Calculate the density of the metal and then determine if this will sink or float in water. And this one's just relating to the density topic that we covered really early on. And if you remember, density is equal to mass over volume. Okay, so in this case, the mass that we have is 35.4 grams, and then the volume we have is 3.11 centimeters cubed. All right, and that's good because if you look at what we're comparing it to, it's also in grams to centimeters cubed. So let's go ahead and do the math here. So this one's pretty straightforward, 35.4 divided by 3.11. And I'm getting 11.3826 grams per centimeter. However, we need to follow sig fig rules. And if we look at the top here, this has 3 sig figs. This has 3. So that means our final answer should also have 3 sig figs. So would it be 11.3, 11.4? How would we answer this?
11.4.
Exactly. So we'd say 11.3 are certain. However, because this is greater than 5, we need to round up. So this would be 11.4 grams per centimeter. All right, so the second part of this question, will this object sink or float on water? Whoops, I forgot my cubed. Here we go. So what do you think? Do you think if it has a higher density, it will sink or float?
It'll sink.
It'll sink. Yeah, if you think about something dense wants to sink down. If something's not dense, it's typically going to float. So in this case, this will sink, which is kind of cool. All right, any other questions on all of this? Did you all find this helpful, being able to see kind of a live review?
Yeah.
Okay,
Yeah,
perfect.
definitely thought it was helpful.
What
I
I
did
think,
have a question
yeah.
about the euros. I missed, somebody came in. Where did you get the conversion for euros to dollars?
Oh yeah, that's a good one. So at the top of this worksheet, I just listed it.
Oh.
So that's actually
Okay.
one you could never memorize because it changes by the day. In fact, this is probably a few years old now.
Okay, thank you.
Yep, no problem. All right, this is great. I'm really happy we could do this. What I'll do is every week kind of check that survey, and if students want a study session on a specific topic, we'll just make a study session and try to get the information we need to be successful. So if you're in 121, I'm going to make another supplemental video after this, but I don't want you to have to burn out sitting through 2 hours. And I'll make a video on using unit conversions as it relates to the mole and as it relates to Avogadro's number. So I'll post that a little later too. But you're welcome to watch that before you do your homework or quiz. Sound good?
Thank you. Yeah, I was really wondering about the Avogadro's number and the atoms. It's a little tricky for me also because of the scientific notation. Again, my husband keeps telling me I should always put scientific notation, and I'm like, well, but it's not asking for scientific notation, so it'll be good.
Yeah, and physicists are the same way, where physicists typically always want things in scientific notation. As an instructor, I find that students have a hard enough time as is doing these conversions. I just want you to do the conversion right.
Yeah.
And that's all I really care about. Yep.
Okay.
All right, well, sounds good. I'm going to stop this recording, and then I'll upload it here in a couple of hours, and I'll try to get the supplemental video for 121 students as well. But if you ever get stuck or have questions, don't hesitate to email me. I know this course can be kind of scary sometimes. So if you ever feel stuck or scared, just let me know.
Okay.
And then Kurt was asking what device I'm using. I'm using my Surface, so I've got a Surface computer. So yeah, that was one last chat question.